First of all, thank you, or hello everybody. Thank you very much for the invitation to this webinar and to give me the opportunity to talk about our experience in Costa Rica. I will switch over to agriculture biogas plants or agro-industrial biogas plants a little bit. So getting away from wastewater treatment plants and entering into the agriculture sector a little bit. First of all, I will present just 2 slides about 80 solutions so that you know who is talking to you. I will speed up this a little bit because of the quite tough time schedule what we have now. We are an independent biogas consultancy engineering company from Germany and doing projects around the world, quite often with GIZ as well, or other development agencies, but also often with private clients around the world. And the services we are providing is consultancy and design and training seminars and plant design. So from plant layout up to plant startup, the whole process we are accompanying till starting up the process and accompanying also during the process of biogas plants. But mostly in agriculture or agro-industrial sector. So we are also involved a bit in wastewater treatment plants, but much more in agricultural biogas plants. And today I'm talking about our activities in Costa Rica. Just to give you a bit of information about the background of our activities that started in 2011. We were hired by GIZ to set up a biogas seminar together with ICE. The ICE is the national electricity supplier in Costa Rica, and we have set up a seminar just with the basics of biogas plants or biogas technology and how to design biogas plants. And afterwards, we have carried out further seminars together with GIZ and RENAG, a German private company active in the sector of capacity building and renewable energy sector. But one outcome of this seminar was that we started to develop several feasibility studies for agriculture and agro-industrial biogas plants. All these studies were financed by GIZ and AEA, an organization located in El Salvador. And these studies were located or were for biogas plants in agriculture sectors or big cattle farms, also dairy farms, a big milk factory or the biggest milk factory in Costa Rica, a big orange processing plant, I think the biggest even in Central America. Banana treatment or banana waste treatment. And amongst all these, also we have carried out 2 feasibility studies or 3 further feasibility studies. One was for the biogas plant Porcina Americana, so that's a piggery with 40,000 pigs, the total closed system, so with small pigs or growing pigs and fattening pigs. Afterwards, they have a own small slaughterhouse, not slaughtering all the pigs, but a part of that. And they have big environmental issues. So they had installed at this time when we started to evaluate this project, they had huge lagoons, anaerobic or facultative, anaerobic, facultative, aerobic lagoons, whatever. But so they were almost settled everything. So the water or the big manure was just flowing through and entered into the small creek and was contaminating the whole valley, more or less, and the valley of Cartago there. And they have a lot of other problems. And so they had the obligation to set up a biogas plant to get rid of their environmental contamination. And so we could start to design this plan. We made a feasibility study, and it was a bit tricky to get environment or economically reliable project out of that, because it's just piggery or just pig manure. We mix it up. Nowadays we mix it up with slaughterhouse waste as well. We designed the plant, what volumes are required. The CHP, so they wanted to produce electricity because there's no thermal energy demand around. And since as Costa Rica is a seismic area, so it's one of the highest seismic areas in the world, so comparable to California or Japan. So installing tanks is quite costly or a bit more complicated there due to the to the seismic area. So the client wanted to install definitely a lagoon technology. And so we have designed the lagoon technology, what is comparable to a CSTR, so to a completely styled tank reactor, so completely mixed reactor. So this lagoon, what you can see over here, is a lagoon with submersible mixers with heating system. So it's a copy of a complete mixed tank reactor or totally mixed tank reactor, but just installed in a lagoon. And the biogas produced is afterwards used in this CHP. You can here see on the left side with in the reactor in the container, a 250 kilowatt CHP producing continuously more or less this 250 kilowatt. So that's a bit of difference to what was mentioned before by Christoph, Bentley, and Carol. It's the biogas production is even higher than we expected before, because there are several reasons. It's especially due to the feeding of the pigs, because there's a lot of feeding is falling into the manure. Anyhow, so we expected, therefore we designed it for 250 kilowatt, or we expected that it's just operating 70-80% of the time, but at the end it operates more or less 100% of the time. So it's producing even more biogas than we expected. Afterwards I will talk a little bit about the problems what we have. Also, it was commissioned 2013. It's still in operation. They have had, or I can mention already, the biggest issue here was really that the electricity produced, it was agreed that they can feed, or that they have a grid connection, so they feed the electricity into the grid. But it has taken years to get really an agreement or a power purchase agreement. So they installed the biogas plant because they had to, due to the environmental concerns. But they did not have the power purchase agreement with a local energy supplier, and so it has taken them years to really get an agreement. And so in the first years, they just produced energy, fed it into the grid without getting any money for that. So they just covered the electricity consumed by the piggery itself and by the slaughterhouse, but did not get any payback from the energy supplier or given the electricity. The more interesting project what I want to talk about is a private partnership for co-digestion of slaughterhouse waste and sewage sludge in Costa Rica. That is another project what came out from these feasibility studies. We have carried out amongst others, we have carried out 2 feasibility studies for 2 different slaughterhouses. These 2 slaughterhouses are 2 of the 3 biggest slaughterhouses in Costa Rica. So they named El Arreo and Matadero del Valle. And we carried out the feasibility study for both of them. Both feasibility studies have shown limited profitability only, so it was more or less profitable, but not really a super business. So the general manager of the El Arreo, one of the 2 slaughterhouses, said to me, okay, if both we are not very profitable, what would happen if we put both waste streams together and just set up one biogas plant? And I said, okay, definitely it would be much more profitable, but they are 2 competitors, these 2 they are still competitors, these 2 slaughterhouses. But nevertheless, the general manager of this Arreo, he called the other slaughterhouse, and they agreed, or they initiated really, and they agreed to work together, and they set up the company Sustratos de la Ribera, so an own company just to set up and to operate the biogas plant. And they installed the biogas plant just beside the slaughterhouse Arreo. Here on the map you can see there's the airport of San Jose directly on the left side, and here downstairs underneath there's the Matadero del Valle, and the other Sustratos de la Ribera, there's the biogas plant and the slaughterhouse El Arreo. So they are just a few kilometers away from each other. And so they agreed that Matadero del Valle, they are transporting the waste to the other slaughterhouse, treating all the waste at this site and using the biogas produced in the slaughterhouse El Areo. So this is the biogas plant installed there. They are treating, it was designed for 71 tons per day of abattoir residues, so stomach content, fat, blood, sewage sludge, because they have at this slaughterhouse, they have already, more or less sophisticated wastewater treatment plant for the wastewater. So they are produced with DAF, with a dissolved air flotation unit. So they are producing sludge, fatty sludges. They are producing excess sludge from the aeration system afterwards, and especially they are producing a lot of. They have quite a lot of blood and stomach content. They are slaughtering their cattle as well as pigs, so they have both of that. They have stomach content of pigs and rumen content from cattle as well. So we designed this biogas plant. It's a stainless steel tank covered with a double membrane and external gas storage. This stainless steel tank had a volume of around 3,600 cubic meters. So everything gets treated together, it's macerated, and then it's treated all together in this tank. Why we have installed this external gas storage is because all the biogas produced is not used for electricity production. That's the big advantage at this site, is that they have huge thermal energy demand, so they use quite a lot of steam for the slaughtering process, and they have some other industrial processes directly at this site. So they have huge steam demand at site, and so we could use, or they are using directly the biogas to produce the steam, substituting fossil energy. Nowadays LPG, before they had bunker or heavy oil, and they switched over to a dual fuel boiler using biogas and LPG. And since the slaughterhouse is just working or operating till Saturday afternoon and starting once again very early in the morning on Monday, so we have around 30 or 36 hours without operation from Saturday afternoon till Monday morning. But the biogas plant is operating or is producing constantly biogas. So we are storing the biogas produced in this time in this external gas storage and in the top of the biogas plant or on the digester, and to just store the biogas produced in this time and use afterwards, beginning Monday morning, they can use all the biogas and operating that. This plant was set into operation in 2016. It's still in operation. It's quite successful. Nowadays, the composition of the substrate has changed a little bit, but it's producing a little bit lower because some fatty waste is not more available as it was designed in the beginning. That's just due to a change of the operation of the slaughterhouse itself. But what I've said, it's operating quite successfully, and the big advantage of that is that of the whole biogas plants or installation is that they can use or treat the quite difficult or quite difficult waste streams like the stomach content and blood, especially. What they had to pay quite a lot of money for getting rid of it before. Now they are treating it in the biogas plant. They are transferring it into a fertilizer, into the digestate, and applying that in agriculture partly, and producing biogas, what can be used, what I've said, for substituting LPG in the dual fuel burner. And what I've said, especially the saving of the cost for handling the difficult kinds of slaughterhouse waste. That's I guess, as far as I'm informed, is the biggest income for the biogas plant itself. The big advantage here is that they have the wastewater treatment plant, and they have installed for the digestate treatment, they have installed 2 centrifuges, and they are separating the digestate into a liquid solid phase. The solid phase is commercialized as organic fertilizer, whereas the liquid phase is redirected into the wastewater treatment plant. So that's the big advantage, that they can easily get rid of the digestate. Nevertheless, it has to be mentioned that the big advantage here was that they have a huge energy demand at site directly, so the steam, so it was easy to commercialize the biogas produced. Additionally, the waste stream or the waste has quite, or the waste what we are treating in the biogas plant has quite a high cost for them. So if I treat it, I can save a lot of cost for the, in this for the final client there. So this is a big income for this client to save the cost for get rid of the, or for waste handling for the slaughterhouse waste. And additionally, the digestate, and often the digestate is not taken into account. You have to take into account for, if we are talking of all kind of biogas plant, it doesn't matter what kind, but in agriculture biogas plant also you have to take into account that the volume what enters into a biogas plant, approximately the same volume of sludge is coming out of the biogas plant. So if we are treating here 70 tons of waste, so what comes out is 65 or 68 or whatever cubic meter of sludge. This sludge is a high quality organic fertilizer, but nevertheless we are talking about 60 cubic meters a day. So we are talking about several huge trucks what you have to get rid of. That has a value, it has a fertilizing value, definitely, but to commercialize that, it's very tricky. It's a challenge really to set up a fertilizer or digester or organic fertilizer market. So that has to be taken into account for every biogas plants to be installed. It's a different case in wastewater treatment plants possibly, but as Stanley said, there are also quite huge problems to get rid of the sludge in Mexico. So it's the same. It's even the quality of agriculture biogas plant, the digester is better than because you do not have any heavy metal issues in agriculture biogas plants normally. But nevertheless, this market of organic fertilizer does not exist. So you have to create a market, and it's rather difficult really, or it takes quite a long time. It's possible, but it takes time. Some additional obstacles what we have faced in implementation of this project. On one side, the permit procedures has taken quite a long time. This client has, he has taken the easy way, so he started construction even before he got all the permissions, and he got it afterwards. So, but it's because in most of these countries, it's difficult, or the authorities responsible for the permissions, they do not know biogas plants, biogas technology, so it's a bit difficult really to convince them or to get these permissions for constructing this kind of biogas plant. Here in this case, afterwards, it was a bit easier because it was just called as extension of the existing wastewater treatment plant. So it was just an add-on on the wastewater treatment plant. Tax exemption of equipment and machinery. In Costa Rica, they do not have any feed-in tariff for renewable energies or something like that. Even it's very difficult to get or to sell electricity to the grid. So the only support or governmental or national support what you can get for renewable energy applications is the tax exemption. So you do not pay import taxes for renewable energy technologies. The problem is that we were talking about pumps, agitators, membranes, etc. So that's something what can be used for renewable energy, but can be used also for other applications. So it has taken quite a long time to get these tax exemptions. And if these equipment arrives in the customs in Costa Rica, or when they arrived, the problem was that they did not. So far, they did not get the tax exemption. So they had to store the equipment in the customs, and to storing several containers in customs costs you quite a lot of money. So at the end, what they have paid for storing the equipment till receiving the tax exemption, I think at the end it was more or less the same money what they have saved by the tax exemption. So it can be what I just want to mention, you have to take that into account or to apply for the tax exemption as early as possible. But it's a bit tricky to schedule this probably because tax exemption, in this case, it has taken pretty long at least. Constructed development, what I've said, all in the seismic area. Additional, we had some issues with the construction side there, but at the end it was working pretty well. Very important startup in these kind of countries, especially in southern or developing emergency country or emerging economies. You do not have a lot of biogas plants in these countries. And for example, this plant, what I've said, we have digester of 3,500 cubic meters. That means to start up this normally in Europe, we would fill up till at least with 1,000 cubic meter or even more with inoculum sludge, so with active anaerobic sludge. Here in Costa Rica, we do not have any biogas plant where we can get such amount of sludge. There's no other biogas plant. So we had to start up with cattle manure and with sludge from the wastewater treatment plant. It's possible, so we started it up, but it takes more time, definitely, and it has to be taken into account because the startup time is, in any case, it's quite long in biogas plants, and it has to be taken into account for your financial plannings as well, because you start creating incomes once the biogas plant is really in operation, and this can take easily at least 3 months, even more 6 months, or in worst case 9 months or 12 months till you really start up a agriculture biogas plants. As more complicated the waste composition, as longer it might take. So this has to be taken into account, especially in the background, based on the situation that in these countries you do not have active anaerobic sludge available, especially in these amounts. What I've said, you need at least 1,000 cubic meters or something like that. So you have to take that into account, especially for the economic calculus or economic planning for your biogas or biogas investment, that it can take quite a long time till you create the first income of the biogas plant. Yeah, financing was an additional issue a little bit. It was not too hard, but we had some seminars together with the local banks, and finally they got both biogas plants I've presented are financed completely privately. This plant has got as far as I know, a low interest credit from a local bank as well, but that was a credit line provided by KfW as far as I know. So, but nevertheless, it was both plants were privately financed completely. Just the project development was financed by, as I've mentioned, by GIZ with its feasibility studies, or there was a pre-feasibility study, feasibility study, so they developed or they accompanied the development of these projects. So I think that was all. Thank you very much for your attention, and I look forward for your questions. Yeah, I'm happy to answer these. Thank you very much.
Thank you very much for your presentation, Carsten, and to all the presenters. I hope that some of the participants still have